You are a bill, not a law. Very good. All right, folks, eyes up here. Here we go. Lots of focus today. Big day. Fundamental theorem of algebra. There is a fundamental theorem of algebra. There's a fundamental theorem of calculus. There's a fundamental theorem of number theory. There's lots of fundamental theorems uh, in mathematics. This is kind of the most important one that you have learned thus far. Why did you not learn this back in Algebra 1? Because in order for it to really mean anything, you have to understand imaginary numbers and complex numbers. And so now that you know about those, we can then write this. Every polynomial of degree n has exactly n roots or solutions or zeros, however you would like to express it. Furthermore, if it has n solutions, we can write it as a factored polynomial with a coefficient. So that means x minus c sub 1, where c sub 1, c sub 2, c sub 3, and c sub n are the solutions. It will then factor to this. Every time we found the solutions to a polynomial, we then have written them in factored form, haven't we? Like we've looked at a third degree, and we've asked, does it factor? And you'll say no. And we go through the rational roots theorem, and we find out that it has solutions of 1/2 and -2 and -1. And at the very end, I write it in factored form. Yesterday, we wrote x minus 1 to the third times x plus 2 times x minus 2. So writing in factored form is an important step. We'll do that today. And then finally, we have this last piece. This is part of the fundamental theorem of algebra. If a polynomial px has a solution of a plus bi, that is a complex number. It has a real part, an imaginary part. Then the other solution must be the conjugate. A minus bi. Complex numbers come in pairs. If you have one, you're going to have a second one. Question. Okay, good. So, yep, she doesn't need help. She just wanted to show off. She's like, I need your help. No, I do. Yes. Sure. So, what we're going to do now is we are going to identify the total possible number of roots. We're going to identify the possible number of real and imaginary roots, the number of positive and negative reals, the possible rational root choices, all the roots of the following polynomials, and we are going to write the polynomial in complete factored form. So the nice thing about this is if you didn't understand what happened, say 3 days ago, this is a chance to continue to review it, okay? And the nice thing about this test is if you understand how to do these bigger type of problems, you can generally figure out the rest of the test. So let's apply all of our learning right now. Number of zeros or number of roots? How many are there? There are 4. So that would say that there are a total of 4 complex roots, okay? The question is how many of them are real and how many of them are imaginary? If I have a total of 4 solutions, how many of them might be real? 4. If I had 4 real, how many imaginary would you have? You would have 0. Suppose I did have imaginary solutions. Would I just have 1? I would have to have 2. Suppose you did have 2 imaginary solutions. How many real solutions would you have? Suppose you had more than 2 imaginary solutions. How many would you have? If you did have 4 imaginary, how many real would you have? So you can see that you're either going to have 4 real and 0 imaginary, or 2 real and 2 imaginary, or 0 real and 4 imaginary. Got it? See how that works? They will always add up to? Yep. C, possible number of positive and negative reals. So, considering these real solutions, 4, 2, or 0, how many would be positive? How do I determine the number of positive ones? How many sign changes? How many sign changes are there in P of X? There's 1. So there is 1 positive real solution. Let's find out how many negative real solutions there may be. I do P of negative X. If I plug in a negative X, does X to the 4th change? No, so I have X to the 4th, and the minus 16 doesn't change either. How many sign changes do you have? 1. So you're guaranteed to have a 1 positive, and you're guaranteed to have 1 negative. True or false? I could have 4 real solutions. False. True or false? I could have 0 real solutions. False. You have exactly how many real solutions? You have 2. They're right here. You have 1 positive and 1 real. So you're going to have this situation, 2 real and 2 imaginary. Of the 2 real, 1 will be positive and 1 will be negative. It doesn't always work out that you can tell that exactly ahead of time, but without even doing any factoring or anything so far, we can already tell what kind of solution we're going to come up with, and that's a pretty neat thing. So we go to D. D says list the choices. In order to list the choices, I have to consider the factors of P, the factors of Q. So the P's are 1, 2, 4, 8, and 16, and the Q's are 1. So therefore, my choices are all the P's divided by the Q's plus or minus. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. Now, before we actually use those, let's try to decide, does this factor or not? Yes, it does. So I don't need to use the rational roots theorem, at least not yet. So for E, let's actually find all the roots, and let's start by factoring. How does this factor? Good. Does the x squared plus 4 factor? Does x squared minus 4 factor? So therefore, you have solutions of negative 2 and positive 2. How do I solve x squared plus 4 equals 0? You could use the quadratic formula as well. We square root negative 4. What's square root of negative 4? Plus or minus 2i. So therefore, my solutions, I have 4 of them. Negative 2, positive 2, negative 2i, and positive 2i. If you roll plus or minus in front of both of them, that's fine as well. Should you be surprised that you have 4 solutions? No, we knew exactly that we'd have 4 solutions. Should we be surprised that we have 2 imaginary? No, that's exactly what we said we would come up with. And notice your reals, 1 is positive and 1 is negative. So you can see that you come up with this situation exactly. The 2 reals are right there, and we have the 2 imaginary numbers. Finally, we are going to write it in factored form. Now, this might bother you, but trust me, you'll use this in the long run. When we write it in factored form, what it says is every polynomial with coefficient a in solutions as follows can be written as x minus the solution. Notice it's minus the entire time, right? So I'm going to choose to write this as x minus negative 2 times x minus 2 times x minus negative 2i times x minus 2i. If you want to write the plus instead, that's fine. I'm doing it now so you don't get confused when we do problem number 4. Okay? Any questions there? All right, let's do the next one. Example 2, x cubed plus 1. How many zeros does it have? 3. Number of real might have 3. If it had 3 real, how many imaginary would it have? 0. Suppose it did have imaginary. How many would it have? 2. If it had 2 imaginary, how many real would there be? So you can see the real solutions start with the degree and it goes down by 2 every time. The imaginary solutions start with 0 and they go up by 2 every time. Could I have 4 imaginary solutions? No, because you can only have at most 3. You have to have one real solution. Was it possible to have 0 real solutions for our last one? For a fourth degree. It's possible for a fourth degree to have 0 real solutions. You tell me this. Why must a cubic have at least 1 real, but a quartic might have 0 real? Right. Yeah, so if you have a quartic could stay above the whole time, right? Or it could stay below the whole time. But if you have an odd degree polynomial, there's no way you can draw it without crossing at some spot. So odd degrees have to have at least 1. There's no way to get from one side to the other without crossing. That make sense? Okay. So this one has either 3 or 1, and then 0 or 2 imaginary. So now I go to, love it when it does that. All right. So the last one is the number of positive and negative real solutions. So positive real, how many sign changes? 0. Negative real. As I do p of negative x, does the 8x to the third change sign? Yes. And the 1 does not. How many sign changes? 1. So I know I have exactly one real solution. It is negative. And I know that I have, in that case, I will have 2 imaginary. Okay? Let's get our choices. This is a 1 and a 1. This is 1, 2, 4, and 8. So therefore, D, our choices are what? 1, a half, a fourth, and an eighth, right? We have to take our P's divided by our Q's, not the other way around. Let's find them. Does it factor? Yes. What form does it fit to factor? It's the sum of 2 cubes. So this sheet has a summary of all the factoring methods in case you've forgotten them and how they go. So what is the cubed root of 8x to the third? 2x plus 1. Now here's how I remember how to do the cubes. I find the cubed root of each of those. I square the front. What's 2x squared? 4x squared. What's 1 squared? Multiply these together. The last one is always positive. This one is opposite that. So that's how you factor the sum of 2 cubes. Oh, I'm sorry, kid. So there we have it. That's the sum of 2 cubes. That factoring method is in your notes if you need to look at it. But yes, that's something you need to know. So what's my solution here? Notice we would have one real solution and it would be negative. The second part, the trinomial of a sum of two cubes or difference of two cubes will not factor, and furthermore, you will not come up with real solutions. So how do we solve that? Quadratic formula. Negative b plus or minus the square root of b squared is 4 minus 4 times a times c. Before you complain about using the quadratic formula, the cubic is a page and a half long, and the quartic is 4 pages long. So quadratic formula is nice and short. 4 minus 16. Negative 12. What is a perfect square? You take out a negative 12. Negative 4. What's the square root of negative 4? 2i. So we have 2 plus or minus 2i roots of 3 over 8. Those are all divisible by 2. So we have 1 plus or minus I roots of 3 over 4. And I'm going to write this like we wrote it yesterday in form of a plus bi. 1 over 4 plus the root of 3 over 4 times I. Or 1 over 4 minus the root of 3 over 4 times I. And we'll use that as we write this in expanded form in a second here. So what are my solutions? Negative 1/2, and we can write 1 plus or minus I roots of 3 over 4. So those are my three solutions. As you can see, you have one that is real. It is negative as we predicted. And you have two that are imaginary. I'm now going to write it in factored form. X minus negative 1/2 times x minus 1/4 minus the root of 3 over 4i times x minus, it's always x minus. Now, later on, if you want to go ahead and, you know, distribute the negative sign through, go ahead. But you might ask me, well, Mr. Gens, can we simplify that more? If you multiply that out, what do you get? 8x to the third plus 1, right? That's what we get. So. All right. Example 3. Degree. Number of solutions. How many real? 3 or 1. Imaginary? How many positive real solutions? How many sign changes? Or if I do p of negative x, I have 0 sign changes. It'll be 0 negative real. Choices. My p's are, my q's are, okay, we got a lot of work to do, right? Each one of the p's divided by 1, and then each one of the p's divided by 2. Plus or minus 1 plus or minus 2, plus or minus 5, plus or minus 10. What do I have after that? A half. Yeah, you would get 1 again, wouldn't you? You don't have to list it twice. If you want to, that's fine. But we get 5 halves. And then we have plus or minus 5. We've already listed it. You don't have to do it again. So there's all my choices. And now we actually find them all. Does it factor? It does not factor. So therefore, we have to go into the rational roots theorem. We have to look at our choices. Um, you're right, Sean. 1 does not work. Okay? So is it worth trying any negative numbers at all? No, because there are no sign changes for the p of negative x. So therefore, we'll try 2. 2 to the third, 8. Minus 2 squared is 4 times negative 13 would be negative 52. 2 times, oh, whoops, 16. Thank you. So 16 minus 52, and then plus 52, and minus 10. Does that give me 0? So if 1 didn't work and 2 didn't work, I have a choice. I can either start trying 5 and 10, or I could try a fraction, say like 1/2. I'm going to give 1/2 a shot here and see how it works out. 1/2 to the third, 1/8 times 2 is 1/4. 1/2 squared, fourth times 13, 13/4. 1/2 times 26, 13 minus 10. What's a half minus 1/4 minus 13/4? Negative 12 over 4, negative 12 over 4, which is negative 3. And 13 minus 10 is 3, get 0. So 1/2 works. So if 1/2 works, what's the factor? If you wanted to, you could write as 2x minus 1 as well, right? Doesn't matter. So 1/2, we go to work. 2, negative 13, 26, 10. Is it negative 10? Okay. Drop it down, multiply. Two x squared minus 12x plus 20. Factor out of 2. Does x squared minus 6x plus 10 factor? No. So I have to use the quadratic formula. Get my discriminant. Discriminant, I get what? Discriminant is the part underneath the radical. Negative 4 squared negative 4. 2i, so 6 plus or minus 2i over 2. So 3 plus or minus I. So what are my solutions? 1/2 and 3 plus or minus I. Finally, I'll write it in factored form. X minus 1/2 x minus 3 plus I x minus 3 minus I. Am I going too fast? Are you guys keeping up? It's a skill to learn. If you go too fast, then all you're doing is writing down, right? So if you're not going fast enough, then you're getting bored. You're super excited right now. And if you go at just the right pace, you're writing down and listening to what's happening. Okay. All right, we got 2 questions left, then you're done. You're keeping good pace. So we have 2 learning targets for the day. The first one is we want to use the fundamental theorem of algebra in order to find solutions to numbers and be able to do everything we just did in the last problem. But we also want to be able to use the fundamental theorem of algebra to be able to write polynomials. Have you ever learned how to write equation for a line? Well, yeah, it was algebra 1. Well, now let's write an equation for a polynomial. So we know that the solutions are 4 and I. Is it possible to have a polynomial that only has solutions 4 and I? If there's an imaginary solution, how many must there be? A pair, right? So 2 or 4 or 6 or 8. So if I is a solution, what else is a solution? Negative I. It's conjugates. So 0 plus I and 0 minus I. So give Kayla a break. She was at a band lesson. How did it go? All right. So we know that these are the factors, or these are the solutions. So what I can do is the polynomial can be written in factored form with its solutions. X minus 4, x minus I, and x minus negative I. Because the fundamental theorem of algebra says if there are complex solutions, if there's imaginary solutions, they must come in pairs. So I is the same as 0 plus 1I, right? That's what that looks like. Its conjugate would be 0 minus 1I, which is negative I. Okay, so that's how we know. All right, so what do you want to multiply first? Well, first we'll do x minus 4 times x minus I times x plus I. Oh, should we do the x minus the 4 times the x minus the I, or should we do x minus I times x plus I? Yeah, let's do the second part, right? Let's do the second part. So we have x minus 4 times, and we'll FOIL this out. X times x and positive I make positive xi. X and negative I make negative xi. And then we have negative I times I is negative I squared. What happens to the xi's? They cancel, and they should because they are conjugates, right? Notice they are always conjugates because that's the definition of the solutions. So they will always end up canceling. It's so nice. So these go away. What is negative I squared? That's all right. Thank you for stating. You guys know my good friend Kelly? Say hi, Kelly. Kelly can have a seat wherever. I'll be with you in be about 5.5 minutes. So x squared plus 1. Now I can multiply it out. X times x squared. X times 1 is x. Negative 4x squared minus 4. So x cubed minus 4x squared plus x minus 4. That is a polynomial that has solutions of 4 and I and negative I. Not too bad. Cam is smiling. She likes it. Like, please, please give me another problem that's more difficult. Okay. Ask and you shall receive. Let's write another equation for a polynomial of degree 3 that has solutions of negative 3 and 4 minus 2I roots of 3. If 4 minus I 2 roots of 3 is a solution, what else is a solution? 4 plus. 2I roots of 3. So we will write it out. X minus a negative 3 times x minus 4 minus 2I roots of 3, that quantity, times x minus 4 plus 2I roots of 3, that quantity. Do you see now why I wrote it as subtraction on the front side? Yes. So that you see what we're doing here. I will get rid of my negatives. I will distribute my subtraction through x plus 3, x minus 4, plus 2I roots of 3, x minus 4 minus 2I roots of 3. There is a shorter way of multiplying this out. However, every time I've taught that, 3/4 of the class has no idea what's going on. So I'm just going to multiply it. If you want to start by multiplying these and you see how the conjugates will work out, you go right ahead and do that, okay? So here we go. I will leave the x plus 3 alone. I'll multiply the rest. X times x. X times negative 4, negative 4x, and x times negative 2I roots of 3 will be negative 2xi roots of 3. Done with the x. Move on to negative 4. Negative 4 times x. Negative 4. Negative 4 times negative 4 is positive 16. And negative 4 times negative 2I roots of 3 is positive 8I roots of 3. We now move on to the 2I roots of 3. 2xi roots of 3 times negative 4 be negative 8I roots of 3. And then we have 2I roots of 3 times negative 2I roots of 3. Let's just do it. What's 2 times negative 2? I times I. Root of 3 times root of 3. So you get positive 12. If you've done it correctly, everything that has a what should cancel. Everything that has an I should cancel. So negative 2xi roots of 3 and positive 2xi roots of 3, they go away. 8I roots of 3 and negative 8I roots of 3 go away. Combine like terms, negative 4x and negative 4x is negative 8x, and positive 16 and positive 12, positive 28. And now I am home free, right? Because there's no imaginary pieces. We did a problem like that back in Algebra 1, right? Where you take a binomial times a trinomial. Let's just multiply it out and be done. X to the third is 8x squared, 28x, 3x squared is 24x, plus 28 times 3, 84. Reminds me of Randy Moss. X cubed. We have a negative 8x squared, a positive 3x squared, make minus 5x squared. 28x and negative 24x make 4x. And then Randy Moss. Good question. To get the 12, I took 2I roots of 3 times negative 2I roots of 3. And 2 times negative 2 is negative 4. I times I is negative 1. And the root of 3 times the root of 3 is 3. Multiply those and you get 12. Remember, multiplication is, starts with a C. Okay, for YouTube Nation, just so you can, somebody should fire me. The district probably will after this because we don't know the right answer. When I said what is multiplication starts with a C, I got conjugate, I got complicated, and I got communist. So, so it's commutative. That means I can move it around. So, you know, that's it. Okay. It's also associative. So, no big deal. No voodoo math here. Your assignment. Full work day tomorrow, folks. Do not take this assignment lightly. You may look at an assignment and say, oh, this is the one I'll skip because I'm sure that he just assigned it to give us busy work. I don't do that. I give you assignments that map to your learning to prepare you to do well on the test. Because study guide I will get to tomorrow. We will get to 3.6 on Monday, finish it up on Tuesday. You have a time to work on Tuesday for half the class, and you will have all day on Wednesday to work, test on Thursday. And this test takes me forever to grade. So I want you guys to all get A pluses. Don't get problems wrong. That's a reality. Thursday.